Hello, the purpose of this video is to look at some graphs and determine if a piecewise defined function is best and how one would use that. So the piecewise defined function is best when there is a change in trend. And so on this particular graph, we have the total new federal student loans per year. And we see that whether we look at the total, the undergraduate, or the graduate student loans, all of them were increasing from the first years of data here in 2006, 2007, up until 2010-11. And then from that point forward, they were all decreasing. And so we have a clear change in trend. We have a trend that's increasing, it reaches a peak, and then it is decreasing. So this would be a great example where we should use a piecewise defined function. And so then we have to decide how to parse out the pieces. And so when I look at this, I'm going to look at the total, and I warn you in advance, my straight lines when I'm drawing with my tablet here are very shaky. But in the first section of the total, it is an increasing trend up until this point, which I think is going straight down the 10-11 school year. So from 2006 through 2011, that looks to be increasing. I look at this, and at the beginning, there's a little bit of a concave up. At the end, there's a little bit of a concave down, which could almost be logistic. But those up and downs are really just a difference of like 1 year it went up a little bit more or a little bit less than the other. So I feel like going logistic is too much because I don't know that there's an embedded exponential. I don't see a percentage change that would give me the idea of exponential growth. I also don't see a limiting value that would give me the idea of logistic growth. So I'm thinking that the best estimator here is probably a line. And again, it would just be an approximation. So maybe something like this, approximately linear. So this part is approximately linear. And it would be from 2006 through 2011. And then from that point forward, it goes downhill. So again, there could be a potentially slightly concave up shape to this, but it looks a lot closer to a line to me. And this is where I can't draw a straight line on technology, no matter how hard I try. So that's not a great line, but I tried. So again, I would say that this is approximately linear. And the time frame for this one would be from the fall of 2011 through 2018. And how would I know that these, okay, so they're both linear, which is sort of the same, but they're clearly very different lines. This line would have a negative slope because it's going downhill, and so it's capturing that decreasing trend, whereas the first line would have a positive slope because it's going uphill, and it's capturing that increasing trend. And I'm not going to write this all formally out because I don't have equations, but as you're doing your assignment this week and you're looking for real data, this is what you're looking for. Where there's a clear change in trend, you want to identify what the trend is and how long it lasts. So let's take a look at another one. So for this one, we have data from this past year where we see the stimulus checks really making a change. But if I look back historically, there was another huge change with the recession in 2008. And so as I look at this data, the first trend that I would see is from 1992 up through 2007. And then 2007 is where we have this drop in 2008. So this first section, I personally would use a line because it looks like it's approximately linear. There's some little bumps and dips in there, so it's not perfect. exactly linear. Things I would note about it is positive slope, because it is increasing through that time period. And so this was 1992 through 2007. And then it asked me what function would I use for 2009 to 2020. So we are going to skip the year of the recession. So we're not going to account for this down, because this is literally a 1-year drop. So we're going to start our next function here at 2009. And again, I would use linear. Now when I look at this, and I'm terrible drawing lines, trying, I see that 2020, so the pandemic, the shutdown of our economy, all that, this is an outlier. So my line does not approximate that dip at all. And then what the graph is trying to portray to us is that in America we got the stimulus checks and spent them. And so we have this point that is also an outlier. And then we would assume, but we don't have the data yet, that we would have come back down to approximately normal and followed this trend line. And so what I would say is, even with those two outliers, the overall trend that I'm seeing here is approximately linear. I again see positive slope that is increasing. I don't see concavity to do exponential or anything of that nature. And my time frame for this would be 2009 through 2020. I went just through 2020 because then 2020, 2021 are where we have all those outliers. So I don't know if the trend continues, but as we would get more data here in 2022, we could make a decision of whether or not those trends were continuing, and we should just include the line even with the outliers. So another example of a change in trend with the recession, the line that we started with did not continue. It wasn't like we jumped right back up in 2009 as if that one blip in data had never happened. We do see that for 2020. We see that like blip in data, that really low value, and then we're like right back on trend. But then we have the stimulus checks, and so then we get a blip the other direction. Maybe we come right back on trend, maybe not. And so with Piecewise, you are breaking the function into pieces based on the trends that you see. And you also see here we skipped year 2008, so our first trend went to 2007, second trend started in 2009, and we just skipped that year because that year is what reset the trend. And we have just these events in world history that reset trends. COVID is one of them that has reset nearly every trend. And so trends that we identify have specific time frames, and that's the idea of a piecewise function. Each piece has its own time frame, has its own pattern.